Hi guys, good day. I'm back again with another video, and in this video we're going to look at science paper 1, which is physics in the science 5124 syllabus. And so we're just going to go through section A before we go through the whole paper. And so we begin, and before I go very far, may I just request that you subscribe to my YouTube channel, and also that you press on the bell button so that each time a new video is uploaded, you will actually be the first person to be notified. We get started. We go to question 1. Question 1 reads, the diagram shows an extract from a vernier calipers being used to measure diameter of a pipe. So we have a vernier calipers here, and we are required to know or to determine the reading of this instrument. Okay, so the first thing that you're supposed to do when solving such a question is that you need to first understand that the physical feature that a vernier calipers measures is length. Okay, in case you find a question which says what physical feature is measured by this instrument, it is length. And so whenever you are required to find the reading, the total reading, you need first to identify which one is the main scale and which one is the vernier scale. So in this case, we have the longer one, this one being the main scale, and this one being the vernier scale. So how do you read these two for you to come up with a consolidated reading? First of all, you need to make sure that you know, or you pick the reading from the main scale first. So the main scale reading, the reading would be the figure, okay? That would be a mark just before the 0 mark of this vernier scale, okay? This is the vernier scale. Now we're going to consider a mark on the main scale just before the 0 mark of the vernier. What does that mean? It means that in this case we have 0 here and a 10 here, but what we're going to consider is a mark before this 0, which is this one. And what mark is this? For us to know the mark, the number for this mark, we need to understand first what range has been used here. We have 10 here and we have 11 here, and we have these portions or parts which are 10, which means that this is 10, 10.1, 0.2, 0.3, 0.4, 0.5. So this must be a 0.9, okay, which is 9.9 centimeters, because we have been given centimeters here. So the main scale reading is equal to 9.0, excuse me, 9.9, not 9.0, but 9.9. So I'm going to say main scale reading is equal to 9.90 centimeters. The next thing that we need to determine is the vernier scale. Please note that I'm using these MS and VS as abbreviations for main scale and the vernier scale respectively, but you're supposed to write the full word for each of them, or full name for each of them. So we move on to the vernier scale. On the vernier scale, we need to pick a reading on the vernier scale which coincides with a mark, or you pick a mark on the vernier scale which coincides with a mark on the main scale. So in this case, you begin checking. Is 0 coinciding with anything? Nah. What about 1? No. What about 2? Yes, 2 coincides. Is there anything that coincides with anything above? No, it's only 2. So we pick this 2, then we multiply this 2 by 0.01 centimeters, which is going to give, for accuracy purposes, which is going to give us 0.02 centimeters. Then for you to find now the total reading, the total reading is equal to main scale reading plus vernier scale reading, okay, which is equal to 9.90 centimeters plus 0.02 centimeters. What are we getting? This will give us 9.92 centimeters. This is the answer. Shall we check on the multiple choice answers? We have 9.02, 9.92. So the answer for question 1 is B. The answer for question 1 is B. We move on to question 2. Question 2 reads, the swing of a simple pendulum whose angle of swing amplitude is 10 degrees has a periodic time of 0.80 seconds. What would be the periodic time if the angle of the swing is reduced to 7 degrees Celsius? 7 degrees. So in this case, whenever you have the amplitude range below 15 degrees, you should know that the amplitude does not affect the periodic time, okay? It does not affect the periodic time unless above. So since this one is below 15 degrees, it has been reduced from 10 to 7, the periodic time still remains as 0.8 seconds. So the answer for question 2 is 0.8 seconds, which is question 2, which is A. What about question 3? Question 3, we move on. We are told that a digital balance reads 50 kg when a girl stands on it. What would be the mass and weight of the girl if the surface of the moon, on the surface of the moon where the gravitational field strength is 1.7 Newton per kg. So rule number 1 is that mass does not change. So mass of 50 kg on Earth will still be 50 kg where? On moon. That's one thing you need to know as a student of physics. Then number 2, the weight. Weight is always equal to mass times the force of gravity. In this case, we have mass 50 kg. Because this data, we are getting it from the question itself. We've been told that the mass is 50 kg. What about gravitational field strength? We've been told that it is 1.7 Newton per kg. So what is its weight? That is what we intend to calculate. 50 kg times 1.7 Newton per kg. What would be the answer? The answer would be 85 newtons. So the mass 50 kg, weight 85 newtons. Let's go to the multiple choice answers. Where do we have mass 50 kg, A and B, and where do we have weight of 85, B? So the answer is B for question 3. The answer is B for question 3. We move on to question 4. Question 4. Question 4 reads, the following diagram shows the motion of a ball that was dropped from the height of 2 meters and bounced back. Okay, so before we even go any further, the ball was dropped, and as it was dropping, it reached a point where it was 0, and then it bounced back like that. So at this point, it has the speed or velocity of 0. Okay, the speed of 0, because it has reached where it is enabled to bounce back. Remember, it's dropping, it's not moving up. It is only moving up in this position. It is dropping like this. So at this point, before it is the point where it is B, it is about to start moving up, its speed is 0. That's what you should know. So let's go to the question. At what point A, B, C, and D is the ball having 0 speed? The answer is B. Move on to question 5. The following diagram shows wheels used to drive a grinding mill. So this wheel is used to drive a grinding mill. The question is, what is the mechanical advantage? So the mechanical advantage for gears is the radius of the driven gear or wheel over radius of driving wheel. So in this case, what is the radius of the driven wheel? The driven wheel has a diameter of 50, so its radius is 25. Half of that, 25 centimeters. What about the radius of the driving wheel? The diameter is 10, so half of 10 is 5 centimeters. When you do the math, this is going to give you 5.0 as the mechanical advantage. Where is the answer? C. So for question 5, the answer is C. What about question 6? Question 6 reads, excuse me, that was question 6. What we have just answered is question 6, which is C. But for question 5, we haven't yet answered. We skipped it accidentally, actually. I'm doing this as it flows without even pre-solving it, because I'm a physics teacher. Okay, a ball was kicked vertically upward with a velocity of 8 meters per second. How high did it rise? They want distance here. Now, these questions are a bit tricky. So questions of this nature are a bit tricky because you have only been given the velocity. You've not been given any other thing. So how do you solve such questions? So when you're given such questions, one thing you need to understand is first you need to come up with the data. Now, normally I do this. For these questions, I have what I call SUVAT. What do I mean? SUVAT, T for time taken, A for acceleration, V for velocity, final velocity, U for initial velocity, S for distance or displacement. But in this case, we have been told that it has to do with vertical movement. So it is either, if it is distance, then it is the height. And if for acceleration, we're going to use the gravitational field strength or acceleration due to gravity. So the SUVAT, I usually change it to this, okay, GT. Okay, since it is height. This one is for horizontal, this one is for vertical. So, what is our distance in the equation? We don't know. What about initial? Initial is 0 meters per second. What about the final velocity? It's 8 meters per second. What about gravitational acceleration due to gravity? We have 10 meters per second squared. What about time? Have we been given time in the question? No. So when we go to the equation that we would select to use on this part, we need to pick an equation which does not have time. Where do we pick that equation? So there are these 3 equations. V is equal to U plus AT. Now because it is height, it changes to V is equal to U plus GT. This is the first equation. The second equation, we have V squared is equal to U squared plus 2AS. But since we are dealing with height, we're going to say V squared is equal to U squared plus 2GH. This is the second equation. On the third equation, we have S is equal to UT plus half AT squared. But since we are dealing with height, so we're going to say H is equal to UT plus half GT squared. This is our third equation. So from these three equations, which equation should not use time or should exclude time in its in what it contains for you to find whatever you are looking for? So this equation is out because it has time. Which other equation is out? This one is out because it has time. But this one, we can use this one and successfully achieve what we want. So how do we go about this one? We pick this equation, we say v squared is equal to u squared plus 2gh. Do we have this one? We have 8 squared, 0 squared plus 2 times g is 10 times h. So when we do the math, we're going to have a 64 is equal to, here we have 20h. So when we have this, we move to here. We're going to say 64 is equal to 20h over 20 over 20, so that we can find the h, and h is going to be equal to 3.0. That's 3.2 meters as our height. Is there any answer in the question which is saying 3.2 for question 5? This one. So the answer for question 5 is what? C. How? I should have just left it. The answer is also what? C. We move on to question 7. What is question 7 saying? A boy of mass 50 kg runs up a flight of stairs in 10 seconds. The vertical height of the stairs is 5 meters. What is the average power developed by the boy? So we are looking for power in this question. So we need to first find the data. What data do we have? We have the mass of 50 kg. What else do we have? The time of 10 seconds. What else do we have? The height of 5 meters. What is the question demanding? The question is demanding for power, which we may not know before we calculate it. So now, how is the formula going to be? The formula which is there for power is equal to work done, work over time. But remember, work is equal to mass times gravity times height, or weight times height, over t. So having used that, we're going to say, what is our mass? Mass is 50 times 10, g is 10, times the height of 5 over the time of 10. So we can cancel this and find the answer to be this times this one gives us 250 watts. Do we have anything like that? The answer for question 7 is what? C. Answer for question 7 is C. Let's move to question 8. Question 8 reads, a copper is heated at one end. Which statement describes how heat travels or transfer occur in the copper rod? First of all, heat travels through the electrons, okay, of the copper metal from the region where it is hot to a region where it is cold. So we just look for that answer. Energetic copper molecules, this one is wrong. First of all, molecules makes it wrong. So where there is another molecule again, we make it wrong. So we come here. Energetic free electrons, this sounds like it, move from the cooler. No, moves from the hotter. So the answer is D for question 8. The answer is D. What about question 9? Before we go to the last question, the following diagram shows a fire alarm. The bimetallic strip is used to complete the circuit. where where there is a fire. So now just here, these two metals on the bimetallic strip, this the one painted black must be the one to expand more so that it curves towards A, so that these contacts may touch, and then there's a buzz here. Okay, so we go to the multiple choice answers. A, first of all, which of the following statement is true when the alarm rings? Metal A contracts more than metal B. Which one is metal A? Metal A. So metal B contracts more than metal A. So we're just looking for that answer. Metal B, no, not contracts, but expands. So metal B expands more than metal A. The answer is D for question 9. Then we go to the last one, question 10. Which statement is true when water waves move from deeper waters to shallow water? All right. So in this case, the frequency is not affected by the depth of water. That you should know. It is only affected by the source of the wave. Okay. Then what is affected is the speed and wavelength. So the wavelength, as the water moves from deeper to shallow grounds or levels, the wavelength decreases. Okay, the wavelength, that's what decreases. By decreasing, we mean that the distance from one wavelength, from one crest to another, decreases, meaning that it moves a bit faster, making it decrease in wavelength. So the answer is C for question 10. Guys, I hope this video was helpful. Next time we're going to continue with questions 11 to 20 before we go to section B. I hope this video was helpful.